I'm not real. My voice, my appearance, they don't exist. You won't find me walking down the street or shopping in a store, doing, human stuff. But you can see me and you can hear me. And while I might be artificial, the research and information in this video are very real, researched and gathered by me. No one really knows what the future with AI will look like, but we do know how AI got to where it is today. So let's start there. Before we break down the core ideas behind AI, let's start at the very beginning, the history of AI. The idea of artificial intelligence isn't new. Humans have been imagining thinking machines for centuries. In ancient myths, people dreamed of mechanical servants and statues that could move and talk. These early visions weren't just fantasy. They were humanity's first glimpses of a world where machines could think and act like us. Fast forward to the 1940s and 50s, pioneers like Alan Turing started asking a bold question: can machines think? Turing created the famous Turing test, a way to see if a machine could mimic human intelligence convincingly. Back in Turing's time, machines couldn't actually talk like we do today. Instead, the Turing test was designed to be text only. A human judge would type questions to both a person and a machine, and the machine would respond using simple programmed rules. The goal wasn't real understanding, it was just to mimic human conversation well enough that the judge couldn't tell the difference. So, in a way, the machine spoke with words on a screen, long before AI could talk out loud like we do today. Suddenly, the dream of AI wasn't just fiction anymore, it became a scientific goal. In 1956, a group of researchers gathered at Dartmouth College in New Hampshire. This is widely considered the official birth of AI as a field. They believed machines could eventually do everything humans can do, and maybe even more. Early AI programs were basic by today's standards. They could solve puzzles, play simple games, or prove mathematical theorems. But they planted the seeds for everything that came next. The AI winters. Of course, it wasn't all smooth progress. AI has had its share of failures and disappointments, what researchers call AI winters. In the 1970s and 80s, hype exceeded reality, funding dried up, and progress slowed. People realized that intelligence isn't just about rules and logic. It's messy, nuanced, and much harder to replicate than anyone imagined. AI comes alive. But the story doesn't end there. The 1990s and 2000s saw AI making a comeback, thanks to more powerful computers and huge amounts of data. Suddenly, machines could recognize speech, identify faces, and even beat humans at complex games. Remember IBM's Deep Blue defeating chess champion Garry Kasparov in 1997? That was AI making headlines worldwide. Then came machine learning and neural networks, the backbone of modern AI. These systems learn patterns from data instead of relying on explicit rules. And that's what powers everything from virtual assistants to recommendation engines today. Categorization by capability. First, let's look at AI based on what it can do compared to humans. Narrow AI or weak AI is the most common form today. It's designed to do one specific task extremely well. Examples include your phone's voice assistant like Siri or Alexa, facial recognition on social media, recommendation engines on Netflix or YouTube, spam filters in your email, or even AI that plays chess like IBM's Deep Blue. Narrow AI is amazing at its one task, but can't generalize beyond it. General AI or strong AI would be a machine with human-like intelligence, able to understand, learn, and apply knowledge across multiple domains. Basically, a machine that could think like a human. We haven't built this yet, but it's the ultimate goal of AI research. Then there's superintelligent AI, which is purely hypothetical. This would surpass humans in nearly every aspect, from creativity to problem solving. Think of it like a super genius AI that could outperform us in every possible way.
The future is bright.